All right, welcome to this talk about Eclipse. Before we start about digging into Eclipse, I would like to give you a brief history of Eclipse. It might be boring, but it's important to understand why Eclipse is popular today. So, like in 2001, I think IBM released Eclipse, it was an internal project for themselves to develop an integrated development environment. And they decided to open source their development so far. And it's been estimated that they already spent like 40 million before they released the source code. So it was a big gift to the open source community. And back in the days, it was like the most sophisticated open source integrated development environment. Therefore, it gained some popularity and became popular nowadays. One big advantage is why it's being used so heavily is like it's a plugin enabled system, so you can add plugins to that. So usually, if you think about development environments, you have something for C++, for Java, for you name it. And with a plugin system, you can basically extend the basic framework that is Eclipse and add your own tools to it. And that's what currently many IDE developers do. Like they use Eclipse as a framework, and then they add plugins to it to customize it to their needs. So what is the IDE in the first place? An integrated development environment. It's basically just a program that has a text editor with like syntax highlighting and stuff like that. And on top of that has usually a compiler integrated, and you can just use a play button somewhere in the GUI and then compile and execute your project that you have. That's usually an integrated development environment. It's like the combination of a text editor and then the compiler, and then you can run it immediately. So how do you get Eclipse? If you just Google download Eclipse, you just have to spell download correctly. The first link that you will have is this download site, and there are certain packages. As I already stated, there are plugins for Eclipse. So these packages is just the base Eclipse with several plugins, different plugins. And on the side here, you can find the supported ones from Eclipse directly from the Eclipse Foundation. So for example, we will be using Eclipse for Java and for C++ in the talk in the morning. And for the talk in the evening, we will be using Eclipse for DSL developers, because I'm going to give another talk about domain-specific languages. There's plenty more of the Eclipse versions, more than you can see here. I'll give a brief overview about some Eclipse versions that are available out there. So you have an overview of how you can modify Eclipse, what products out there exist, how have they been modified, just to give you an overview of what you can do with Eclipse in the end. And so I assume that everyone has downloaded the Java or C++ version of Eclipse. Let's start with the Java version. If you download it, the zip file, I will just demonstrate the Java version with Windows. You unzip it, and then you have like the executable file here. And by the way, there are two different versions, 64 and 32-bit. Back in the days, like 6 years ago or something, everyone recommended using the 32-bit version, because Java back then was 32-bit and Eclipse is based on Java. And the 64-bit version of Java was not that sophisticated, so everyone was recommending 32-bit version. I still go that way, I still use the 32-bit version usually. 64-bit version nowadays might be perfectly fine too, but I'm just using 32-bit. Yeah, and by the way, since it's based on Java, it's sometimes a little resource heavy, but we will see that later. So if you start Eclipse, did I start it? No, I didn't. Yeah, I want to run it. It will start with an empty welcome screen. Oh no, it's actually the workspace. Okay, workspaces. In Eclipse, we have the workspace concept. Every time you create or you start Eclipse, it asks you for a workspace, unless you specify the default one. And workspaces are basically an environment where you want to program in, where your projects are, and where also all your settings are. So you can have a workspace, for example, for your personal projects, for your projects at university, and then switch back and forth. And you have your customized workspace for every environment. So if you, for example, specify a set of tools for the university projects, then you have in this workspace this workspace will look different than your workspace that you're using for your personal projects maybe, and everything will be saved in the workspace. So that's pretty nice. And I'm just going to create an empty workspace here. I think of that. And I'm going to set it as default one. And this is the welcome screen that I was talking about. You can usually just hide it or just click it away. Then you will end up with that. It might be a little bit much for someone who starts it the first time, so I recommend removing some things. For example, the task list is like a to-do list of teams, so it's like a collaborative to-do list. You probably don't use it. The outline usually is also not really necessary, just remove that, and there we already have a lot of more space. So we also don't want the Java doc, let's just also remove that. The declarations, also remove that. And we can just if you minimize it here, then you will end up with like two views as you're used to it with most of the editors. On the left side, you have an explorer of your files, and on the right side, you will have the code, which is pretty nice. So let's go ahead and we'll start a quick Java project. So I say new and Java project. And it will ask you to specify some certain things. So we'll just name our project test. You can specify a Java runtime environment, stuff like that. But for this small example, we just did finish. And then you will see on the left side our test project. And if you open it up, we have a source folder, we have the Java environment, and that's basically an empty project. And if you're familiar with Java, the first thing that you will do is probably create a main class or a class that contains a main, so you can execute the entire thing. So you say new class, and then we'll just specify main. And we also, because we are lazy, we just check this box here, this checkbox, that automatically will generate our main for us, so we don't have to type it. And then we'll just hit finish. And there we are. In our test project, we'll have a main Java class, and in this main Java class we'll have a source code. So if I, for example, go ahead and type system, and I should be correct here, this capitalization system.out.println, hello world. No errors, as you can see, and I can now go ahead and press the play button. Yes, I want to save everything. And you can see my console opened, and it says hello world, which is nice. So you can see I can easily get started with something. And next I want to get over to the concept of views, because I just restore it for a second again. You can see that we have all these views. We have a package explorer here, we have problem explorer here, we have a console here, and there are plenty of more views. So if you go to Window, Show View, and it's just the other, you have like small subcategories, and you can have like a dozen of different views that you want to have. So for example, let's go to, how about type hierarchy? I just want to have a look at the type hierarchy, open that up. Okay, that might be a bad example. And just open the outline. It might be simpler. Where's the outline? There's the outline. We closed it at the beginning, but I'm just going to reopen it for a second again. In the outline, you can have a hierarchical view of your project, for example. You can easily jump in the functions. So if I'm going to create a new function here, public void test, it appears on the outline, which is pretty nice. So for different programming languages, you will have different views. For example, if you have like maybe there are graphical editors, for example, for Eclipse, you will have a view for like a drag and drop GUI editor or something like that, but you will see that later. So let's just close it again to make everything a little bit more clean. So and I want to get back to the text editor itself. As you can see, that's pretty basic. We have syntax highlighting, which is pretty nice. You might also already have seen it, that it automatically warns us or gives us errors if I make something wrong. So if I don't spell system correctly, it will give an error, which is nice. And what's also nice, I'm pretty sure that it will give us a quick fix. If I hover over it, it gives us a set of solutions that might solve our problem here. Apparently, our solution might be, there it is, change the system. That's what we've meant. That's a quick fix. If you have a problem, and then it will give you a quick fix. So let's, for example, thread.sleep. I know that this function usually returns or throws an error, and errors have been caught in Java. So it will give us an error message saying unhandled exception type interrupt the exception. So it will give us two solutions: add throws, that is like the hacky one, but the modified one is probably sort of try catch. So it's a pretty handy tool for you to, without even compiling, letting you know what is wrong with your code and helping you with, in the case if something is wrong. So let's just remove that. Similar to other editors, you also have like shortcuts. Like for example, if I type siso and hit Control and press spacebar, what is it again? Damn it, I forgot the shortcut for that. Siso, yeah. Apparently it is not. Why is it working? Okay, I'm sorry for that. I probably need to show it to you later. Anyway, there are other shortcuts. Let's just have that. That's code completion. So if you can see system, and system has a .out, and the out has a print line. If I want to see what is in system, I can just press a dot, and it will give me all the stuff that is in system. And similarly, if I'm a main class, I have the test function. If I want to see what is in my main class, I can type this, and then it should give me. Oh, it's in static. I have to create an object first. Main handle new main, and then main handle dot test. That is. So it has code completion for you. You can easily browse through the stuff that is available, which is pretty nice. So let's just go with that. And it works perfectly fine. So let's just have a look at other features from Eclipse. There are source tools which you can implement. Some functions that are usually like implemented like for Java, you probably have something like some attributes within your class. Let's just say string tests and private int number or whatever. And usually you have getters and setters to access those private members of a class. So you can generate those if you hit source and then generate getters and setters. You can generate the getter for test number and setter for that, and just say OK, and it will automatically generate the getters and setters for you, which is pretty nice. Similar to that, let's just say new thread run. This hopefully works. Didn't try this in a long time. Runnable. Yeah, there we go. So I made this private in a subclass, and it won't work that way because it doesn't have any no body. But I don't want to spend any time why it won't work. But it will Eclipse is smart enough to be able to give you the option to automatically add unimplemented methods. So if I click that, it will automatically generate the method head for me. So I can just insert my stuff in here, which is pretty neat. So after we've seen the Eclipse version for Java, I'm now going to transition over to the Eclipse version for C++. So you can see the similarities or dissimilarities, however you want to call them. So I have Eclipse, that's DSL. Okay, and I don't have anything here. Okay, let's go with that. So this is a already running Eclipse program. I'll just switch the workspace, so we'll have an empty workspace. I'll just say file, switch workspace, other, and I'm just going to create an empty workspace for me. Okay. So now if I switch over to this workspace, I will have an empty workspace. So you can see that it will look similar to the Java version in a minute. Here we go. We can just close the first window again. Oh, and apparently I have a basic Java version. Okay, usually if you start the C++ Eclipse, it should start in the C++ perspective. Since I apparently have a Java version as a base class, I'll just hit the button up on the right corner here and switch the perspective. I'm going to say about something about perspectives in a minute. And you can just select the C++ perspective, and then you will be switching over to the perspective. Okay, since I now use the perspective, I should probably introduce what a perspective is. And has my cursor been that way all the time already? I'm just going to, that's interesting. And the other cursor is probably from the other computer. It's just me. Okay, here we go. So, since the Eclipse framework is based on plugins, they came up with the idea of having perspectives. So, usually or sometimes you can have one Eclipse for all the programming languages you have, for C++, for Java, for Prolog, for Scheme, for everything, just with different plugins, and you can switch between them through the perspectives up in the corner here. So I now have a Java and a C++ perspective, and I can transition back and forth. There's another approach that I usually go with, is having one Eclipse for every programming language that you have. So that way you won't pollute like one Eclipse with all the stuff that you have. That is pretty nice. So I usually go with one Eclipse for every programming language that I have. So I'm just going to close that view here. And again, you will see things that you might not need. So I'm just going to close the outline, the targets. I don't need the tasks. The properties are also not needed. And then I'm going to minimize the bottom view. And there I'm back again with a pretty clean environment. It's a little bit easier to understand. And by the way, sorry for the cursor. It's probably because of the virtual machine. So what if you want to create a C project? I just go new and say C project. That's pretty similar to what you've seen with Java previously. Just go to the Project Explorer, right-click, new, and then project. And in our case, we want to create a C project. So let's just create a test C project here. And here we go. We have a project again. Now this time we won't have a source folder, but the source folder is something specific to Java. But we can create C files. So let's just create a source file. Do we have templates here? They are all empty, so let's just say main.c. It doesn't really matter much. There's my main.c, and in the middle you will see that this is my editor. And let's just remove that. And it's pretty similar to the Java version that you've seen earlier. Now let's just let me just insert some C code so we can work with that a little bit. What I'm going to use. Let me just. Which one I use? It doesn't really matter. Okay, I just copy and pasted some code from a previous project into my main file here. So I can show you a few things. You can see that there are a bunch of errors currently, but that's probably just because I didn't save it, because in the top in C files, or C++ files, you have the includes. If you don't save, it doesn't update the internal structures for the includes. So if it's save, it should, yeah, and now all the errors are gone. So again, similar to Java, you will have the automatic hints for wrong code. So if I, for example, say int and I misspelled int, you will see that it will complain, which is pretty nice. This way I don't think that it will give us quick fixes. Yeah, it doesn't give us quick fixes. So we can easily fix our mistake without even compiling it, which is nice. So I gave you all the time the instruction to use C99. So you're used to specifying it in the command line, like gcc-std equals C99. With the Eclipse, you can hit on the project, right-click, and say properties. And then you have certain properties that belong to that project. And you will have this C++ build tab here. You can go into it, and you can specify certain attributes for making your project. And the interesting one is in settings. In settings, you will have all the most common settings for the GCC compiler. So if I go to dialect, I can set C99 here, which is pretty nice. And if you go back to the C compiler, it will add the -std equals C99 for you. And if you hit enter, or if you hit OK, it will be automatically saved. And by the way, one hint about the tool chain for C++, if you run it with, if you use Ubuntu or certain other Linux distributions and use the Eclipse version with C++ for Ubuntu, usually everything is perfectly fine as long as you have the build essentials installed. If not, just apt-get install build essentials and it will work. On Windows, it's a little bit more tricky. You have to have a compiler, and you will have to set the compiler within the Eclipse environment. Some people go with the Visual C++ compiler, others go with MINGW. I don't know how to pronounce in English, so I'll just MINGW. And on Linux, you probably don't have to do these things. That's why I'm using why I'm showing you this stuff in Ubuntu instead of the Windows that you've previously seen. So if I go ahead and say save, and this small hammer up here is for building the project. So I hit the hammer here, and you will see in the console that it invoked the make file for you, and it also, you can see here is the GCC, and it would also warn us that we didn't use the ASDF. So we can, it also has a nice warning here, you can basically just remove it. Let's go again, and this time we compiled without any warnings. Yep, everything's perfectly fine. And you will see in your Project Explorer, you will have a debug folder, and in the debug folder, there is your binary, and there is also all the object code and the make files and all the stuff like that. And it's called debug because our build target was a debug environment. For C and C++, you usually have a debug and release environment. So this is debug, this is release. And if you go to release, for example, you have, for example, O3 optimizations enabled. And for the debug environment, you usually have no optimizations and full debug information. So that's one common way for almost all of the development environments that work with C and C++, that you have target for release and a target for debug. Okay. So if I hit to run again here, it should run my project. Did it? Yeah, it did run my project. This is the output of the project. Never mind. It works. That's nice. And let's just go back to Java for a second again, because I want to show you the similarities. We've seen the right-click on the project properties for the project. This is basically the same here. I can right-click properties, and then it looks a little different. So here's no C++, but we have Java, and you can go through it and set some configs for Java. But you not necessarily need this for Java. For C++, it's more common for Java. Usually the default ones are perfectly fine. So what I'm going to show you next. How about debugging? Okay, you used to GDB for debugging with C and C++. You didn't see Java so far, so I'm just going to give you a nice, quick introduction to debugging with Java. It's basically similar to that. You can set breakpoints by double-clicking here in the leftmost column of your editor, and then you'll set a breakpoint. And let's just remove the to-do here. That's not very okay. And I'll just get rid of the warning. No. So now in the left column, only the breakpoint is set here. Let's just also specify something in here. It doesn't work anymore. That's strange. So if I go again, and this time if I play, it will run as you're used to it. It will print hello world and ASDF because I called it in here. And if I hit the bug here, it's the debug functionality. So I just press it. Okay. It will ask you to change the perspective. As I told you earlier, the perspectives are like Java, C++, whatever. There's also a debug perspective. So if I open the debug perspective, you can see here there is a new perspective. So the Java perspective that we're used to, and then this new debug perspective. It's pretty nice to have that because in the debug environment, you sometimes have like the stack stack frame. It's not the stack frame. The stack hierarchy, the calling hierarchy. We also don't need the outline. You have variables and the content, stuff like that. So your debug environment usually looks a little different from your development environment. That's why it's nice to have the debug environment. And as you can see, I removed a few things that we don't need. So you can see this line is highlighted. It basically means we broke at this breakpoint. I hope broke is the right word for that. And then we can step over our code. And we can step over our code with the arrows here. So what I usually do is I hover over the arrows and see, okay, step over is F6. And step into is F5. And then I use the F6 and F5 shortcuts for that. So if I press F6, it will step over, go to next step, and will print hello world for us. If I hit F6 again, nothing will happen except that our main handle will be created. And it has a number which is null and a test that is null. Okay, that's nice. And if I hit F6 again, it will print ASDF because it will have called the test function. So let's give you a little bit more introduction. Let's just terminate it. Change our code a little bit so you can see a little bit more. Let's just print or test number. And by the way, one nice thing for foreign speakers is it also has like a spell checker. So if I does it have to save it? Okay, does might not work for strings. How about comments? This is misspelling. Yeah, here we go. It has some spell checking for you, which is pretty nice for foreign speakers. Again, through our debugging. Okay, that should work. And I want to specify that this is from the reference. And now I'm going to remove the code a little bit so it's easier for you to understand what's going on here. So, done. Okay, here we go. Save again, and now I hit the debug button again. I'll transition over, and I just want to remember the decision for now. Transition over to the debug view, and there we are again. We can step over with F6 and F5, but it might vary from program language to program language, so always hover over it, and I see, okay, F6, F5. And then I can hit F6, F6, and so far nothing changed to our previous debug session. What I want to do now is I opening up the variables here, and I can also, I think I can hover over here, and I also see it here, yeah. Let's just change this on the fly to something. Come on, test. Oh, doesn't need parentheses, test. And if I press F6 again, it will this time print test and the number because I've changed it. If I just run it, it might complain because of the null. Oh, no, it doesn't. You can see if I didn't change it, it prints null and serial number. So I could modify variables on the fly, which you can basically also do with GDB, but it's nice to have a graphical user interface for that. And the last thing that I want to show you in debugging is I can also step into, which is the F5 here, or just press a button. And then I'll step into the function, and I can just step through this function and step for step go over it, which is pretty nice. So here we go. And let's have a look at how is debugging being done in C and C++. So I'm going to open my C++ here again. And it's basically the same. You just set a breakpoint. I'm just going to set a breakpoint right at the start. And then you have the debug button here again. You press the debug button. It might take a while for compiling and running. OK. And yeah, I want to remember the decision. Again, we have a debug perspective opening up. We have the same layout. We don't want the outline. Just remove that. We don't have more space. We have a little other things here for C and C++ because, in C and C++, it's nice to have a look at the assembly. So let's just open the assembly up. Show view disassembly. Here we go. And here we have our C++ code or C code up top. And then the assembly right below here. And if I step over, again, it's F6. If I step over, you can see that it will move in the disassembly view. So can you see that? Hopefully. In the assembly view and also in the CFox view, which is pretty nice. And again, I have these variables which I can go through. I can modify it on the fly like you're used to, or like you've seen it in Java. You have in C, because it's basically assembler, you can also have a look at the registers which are in your computer. And the one thing that I want to show you is how does it work in the background. For C++, it uses GDB. To prove that, I'm just going to open the console here, and I'm going to switch. You can see this console view represents multiple consoles in the background. So usually, if I'm just going to execute a program, the console will just print our std out, whatever. Let me just open it again. And in the debug view, we'll have a separate console, which is basically our GDB console. Is it already running? Yeah, it is. OK, in the GDB console, let me just open it. Is it that? Help. Here we go. Print. What are we going to print? EVP. Here we go. So it's basically just a user interface on top of GDB. So if you want to use the user interface, you can just use the user interface if you're more familiar with GDB. Or if you want to do something and you know how it's done in GDB, but you don't know how to do it in the user interface, just switch to the console and you can just use GDB, which is pretty nice. And by the way, as you can see up top here, I currently have 2 debug sessions running. And let me just terminate one. You can see it's terminated and go back to the other. Here we are. Screen is all a little bit small. And just as you used to Java, we can step over and we can also step into. Do we have a function somewhere? OK, this might take a while. Do we have a function call somewhere? Here we have a function call. So if I set a breakpoint here, hit the play button, it will break at the next breakpoint. Here we go. And I can press F6, F5, and go into the function which I'm calling with step into instead of step over. And that way you will get a really nice user interface for debugging, and it's pretty handy. OK, let's just terminate that. I have my nice to-do list here, and I think next on my to-do list is a little bit about refactoring and working with the text editor. So, for example, I'm passing an argument here which is called vertex1. If I click on it, it highlights all the occurrences of vertex 1. It's just one that's a little bit less. It's what vertex 2. Do I use vertex 2 a little bit more often? Also very often. How about vertex 2 do? Do I use that more often? A little bit more often. OK. How if I decide during the development that vertex to do might not be the best name for my variable? Well, I could just search and replace, but it might be like a dull task to do, just replacing all the occurrences, and it might be error prone, especially if you replace like global variable names. If you have a global variable name that is used 1,000 times, you don't want to go over it and manually replace it, all the occurrences. So you can just right click and say refactor, and then you can hit rename. And that way I can give it a new name, and you can see it will automatically update our occurrences, which is nice. And hit enter, and then everything will be overwritten. Since I want to have my previous version, I just undo it. OK. For development with C and C++, I don't know, sometimes it might be a little bit dull to look all the libraries up for, like, if you want to measure the time or something like that. And there's a little bit more convenient way in here. Let me just have a look at, OK, let's just have a look at malloc. I know that malloc, OK, I've already shown the secret. If I want to use malloc, it has like a certain signature, arguments that the function expects, and some return values or one return value. You can hover over it, and it will give you the definition of how it's defined in the include file. And furthermore, I can also right-click on it and go to the declaration. And here we are. We found the declaration of malloc inside of the stdlib.h file, which is pretty nice. So you have if you have a function and you don't know where it's coming from, just show where it's have a look at where it's declarated, and then you will find it immediately. OK, similarly, you can do stuff like, OK, I have my function here, has root. I want to know where my function is being called. So what I'm looking for are the references. So I'm clicking on it, and then I say references, and I want to see the references that I made to this function in my workspace or also my project. set project. And then you'll see, okay, I have one reference, it's being called once in here, which is pretty sparse. Okay, let me transition over to, do I have, okay, a little bit more complex. This is another Eclipse instance that I have open. Just want to give you an example of a little bit more complex example. So let's just have a look at, you don't need to pay attention for the code or for the details, it doesn't matter much, but what if I want to see where I'm calling the clear function here? This is by the way Java, so you can see it's pretty much the same. References in my workspace. Oh, also only one. That's disappointing. I expected more from it. Anyway, if you have multiple occurrences, there are multiple occurrences showing up. And similarly, I'm just going to stick with this workspace for a second. If you want to search something in your entire workspace, if you, for example, have multiple projects and you realize you made a bug and you have the bug maybe in different projects that you have previously done, you can search either by pressing Ctrl F inside of the current text to a current file that you are in, like you use with normal editors, just search and replace, stuff like that. That's pretty common. And you can also search for a file in the entire workspace. Okay, let's just search that. And it will find every occurrences of that in the workspace. So I can see I have 3 occurrences of that in the workspace, which is pretty nice. And by the way, just small hint. I can also, that's also pretty common, search for regular expressions and locally in a file and globally in my workspace. So where is it? Here I can hit regular expressions, and you can type regular expression to search something, which is pretty convenient. Okay, let's go back to C and C++. I'm going to back to my other workspace because I have made a few settings there that might be important right now. So we've seen refactoring, that you can rename a function, for example. You have useful tools for finding references, for finding declarations. What I want to show you next is formatting. Formatting is a pretty nice tool. I mean, it's nicely integrated in here. So if I, for example, open the same maze project in here, you will see that. Okay. You'll see that I have a certain coding style that I apply. So for example, my parentheses start here and not in the new line. And every company usually has its own coding style, and you have to stick to the coding style. And sometimes it might be a little bit dull task to stick to their coding style. That's why you can pre-configure a coding style inside of your Eclipse version or Eclipse environment. You can usually they give you like a config file, and you can just import that. And now if I set source format, or also just I usually hit Control, Alternative, and F. No, Control. Oh, here we go. Control, how's the key called again? Where you make something capitalized? I don't know. Shift, yeah. Control, Shift, F, and will automatically be the shortcut for, thank you, for formatting. So if you have seen, I made the curly brace in the new line. Maybe some coding styles want you to do that. I don't. So my coding style, if I hit format, it will automatically format my code how I want it. And similarly, let's just make some garbage. We have a for loop somewhere. I have a for loop in here. Let's just make the for loop in a really strange way. I don't know why somebody would do it like that. And now I Control Shift F, and it will format it for me, except that one that apparently didn't work that well, but it works most of the time. Also, if I have like 2 spaces or something, 2 spaces are usually not really useful, so my formatting rule will remove the space. So the question is, how do I format, or how do you configure the format rules? Because for you, it probably, if you hit Control F, it would screw up your code and format in a way you might not want it to. So, okay, I hit the C and C++ and then the code style, and then there's a formatter. In the formatter, you can see my active profile is mine. I can edit it, I can specify certain rules, like, for example, that I want to use tabs for indentation, that I want to have braces always on the same line, and I want to have certain white spaces the spaces in between. So for example, somebody might not want to have a space between the assignments and the equal sign, so maybe somebody configured it that way that there is no space. And let's just switch over to a different style. Let's just use Carnegie and Ritchie. Okay, and if I now format everything, it will look different. Okay, it will look different because it has like a maximum width, it specified a maximum width of 80 characters probably, so it formatted a little bit different. Yeah, but that's probably the only big difference. Let's just use a different coding style because it's a little bit disappointing if only the lines are broken. Let's just say how does it look like? Looks more interesting. How about BSD? Doesn't matter much. Okay. If I hit Control Shift F now, you can see that this coding style wants to have the curly braces on the next line, so we'll automatically place all the curly braces on the next line. But since I like mine, I'll just switch over to mine again. Oh, come on. Here you go. And here we go, mine is back. And I'm just going to undo everything. Yes, okay, so everything is like I'm used to. How about formatting it in Java? Because we're currently looking at C and C++. Let's just switch over to the Java workspace or to the Java Eclipse. It's basically the same. What happens if I hit formatting now? Okay, nothing really much happened. It's probably the default one. This time I don't look at the C settings, but at the Java settings, and then I can specify the code style here. And the Eclipse formatter pretty much looks like what I've already done. How does that one look like? Also not much different. So what if I do it like that, what will happen? We'll see in a second. Yep. Oh, it apparently doesn't. Do I have to do that? Okay, now it works. So it doesn't catch all the formatting issues, but most of them will be caught. And it's a nice tool. It's like it's always like pleasing to see when you write your code. You hit the format and everything, the format function and everything will be like nicely looking. It's always nice to see that. So we've seen that, okay. How about, I made some changes to my program and then I found out, oh snap, I made some mistakes. And let's, for example, close this for a second. I want to save the changes. And now I can't use the undo function anymore that you're used to in your text editor. If I open it again, you can see if I said edit undo, undo won't work because when I close the text file, it will erase the history. It doesn't have to keep it. So how do I get back to my old state? That's a good question. I mean, I didn't do anything. I didn't save anything. I have no backups. So that's a pretty unknown feature, which is pretty sad that it's so unknown because it's pretty useful. It always takes me a few seconds to find it. Compare with, there we are. I have a local history. So Eclipse in the background makes a local history of my changes, which is pretty neat. So I open the local history and can see I made certain changes. So let's just go, maybe the version from 10.33, it's nice. Okay, I can see, I clicked on that and will show me the differences or what I was doing. It's really convenient to have something like that, and it's showing me in a diff view. So it's like you're used to a skit of something, for example, where you see the differences. And I can transition back to old versions if I screwed up or something. Or imagine that like your computer crashed. If you then go up to power up your workspace, usually you don't have the undo function anymore because it's like forcefully quit everything. So that way you can rescue your changes without having saved them, which is pretty nice. All right. On my list there's Git and something like that, so we'll have a look at that later. But I told you that there's a plugin system basically. You can install new plugins. They might not have chosen the best user interface for that because if you want to install or update stuff, it's like unhelp, and then install new software or check for updates. And if you want to see what's currently already installed, I don't know why they did it, but you hit install new software and then there's this small blue text that states already installed, and then you will see what's already installed, which is basically just the Eclipse bare version for the Java environment. So what if I want to download a new language or something? There's this default update site. You can just have different update sites, and I just use the release update site from Luna, and it will fetch different plugins that you can download. Might take a while, sorry for that. It's taking longer than I expected. Okay, let me do something in between. Not all plugins that you might use or want to use are in the official update site, because you need to get through the certification process to land in their update site. So what if I have when I have a plugin that is not really common? For example, they have a marketplace, Eclipse marketplace. It's like an app store basically for plugins, and you can go over them and see what plugins are available. Currently 1,600 plus a few, maybe around 2,000. Oh, there it is, 1,800. So maybe you want to have like a different syntax highlighting, because maybe you don't want to have a white background. Oh, it loaded. Maybe you don't want to have this white background. So what we're going to do in a second is maybe just looking for a tool, plugin that changes the syntax highlighting for you. Anyway, it loaded, and you can see this is the default update site, and you can have I installed the Java version, or I'm currently running the Java version of Eclipse. So if I want to have the C version inside of my Java Eclipse, I can just go ahead and set languages. There should be language somewhere. Does anyone see languages? Programming language, there are, thank you. And you can install the C++, probably development tools. And that should be it. And then you can install it. And by the way, as you can see already, there are many different C++ plugins. So for example, if you work with a Qt framework, you have a plugin for that, which is probably also pretty convenient. But I don't want to install it right now because it probably takes quite a while. Let's transition back over to our formatting tool, syntax highlighting. Let's just formatting, syntax. Oh, no screenshot. I don't want to make a screenshot. Syntax highlighting. I'm pretty sure that there's a popular tool for that. Oh, I think they call it code style. Code style. Okay, apparently the marketplace is not really helpful for us. Code style. Plugin, that's what I want to use. Check style? No. Okay, I apparently can't find the plugin right now, maybe later. Otherwise, if you find plugins, they usually provide you with an update site. You can insert the update site up here, and then you can insert or download the plugin. I know one update site real quick is, for example, that's pretty easy to access, Android update site for Eclipse. They usually have it conveniently somewhere. Yeah, for example, if you want to download the Eclipse plugins for Android, or the Android plugins for Eclipse that way around, you can just insert the update site from Google up there, and then you will be able to download the Android plugins. All right. So about the code style that I told you earlier, we can also manually specify a code style ourselves. Let's just specify code style. Here we go. Code style. Oh man. Editor. Text editor. Here we go. We can specify our own colors for keywords, our own background color for that. But a plugin would be nice. Maybe I'm going to show it after the break, something. So let's get back. By the way, we've seen the formatting tools with Java and C++. With Java, there's a second formatting tool, or there's a cleanup tool. It does not only format your code, it can also clean up your code. So for example, if you have, in Java, you usually have let's just use thread.sleep again. you have these imports. And why don't I need thread.sleep? Okay, this is probably one of the default ones. What is the not default one? Vector should be not default. Vector string test. Vector is not default, yeah. So I'm importing it. This is similar to the includes that you use to C++ and C. Once I remove it, it won't use import anymore. And I can either go ahead and manually catch all those, or I can also just hit source and not format, but this time cleanup, and say next, and then it will give me the difference between the old code and the cleaned up code, and it removed the include there, the import there. So if I hit enter, it will replace it. By the way, the cleanup is also pretty handy if a big project and you want to format the entire project. So for example, let's just open that project. It's pretty big. I'm just going to introduce like 2 blanks in here. That should be caught. Save it, and now just import something that is useless. Import java.io. Do I have a buffered reader? Yeah. So I don't need a buffered reader here. But now if I clean up my entire project, source, where's source? There's source. What? Then I have to hit here, source. There we are. Cleanup. I'll have a difference view of the cleanup of my entire project, and it should have caught the useless import here. And I can see immediately how it looks like after the cleanup, and also the removed spacebars. So finish, and it will have fixed that for me, which is pretty nice. And sorry that I didn't show you that earlier. It might have been more appropriate to show it to you once I introduced the formatting in general. But here we are. Okay, so we've seen the local history. Let's make the transition over to JIT and eJIT. If you work with projects in general or in teams, you sometimes or mostly have like a source repository like Git, CVS, SVN. Nice thing with Eclipse, like a year or 2 ago, they introduced eJIT, which used to be a plugin obviously, and now they introduced it into Eclipse all the time. And eJIT helps you to integrate Git in your program or in your project. You can easily like use Git in the project. So how you do it is say team, since you want to work in a team, and say share project, and then you can select the source repository that you want to use. So I want to use JIT or Git, and you can see that there are no repositories available because I didn't specify any. I want to just create a repository in the parent of the folder of the project. This is usually discouraged. Does it say that? Repositories? Well, yeah, it's not recommended because it's a little bit inefficient for the Eclipse framework to keep track of the workspace if all the Git files are in there. I don't care right now, and it's as simple as I just say create a new repository, say finish, and now you can see it changed a little here in the project explorer that this file has a question mark. It has a question mark because it's being untracked. If I say team, now team will look a little different. Add to index, it will look slightly different. Okay, now it's added, but we didn't commit it yet. And now we can say team and commit. And I have to specify my credentials, that's perfectly fine. Let's just, yes, what is in there? Compare with that. Okay, let's just commit everything. You can see I manually added the main file. I didn't index the class path, the JIT-ignore project, and this press file. So if I want to commit them all, it will automatically add them for me without specifying that I want to add them explicitly. And then I can specify test message, hello from Simon, whatever. And then I can say commit. And you can see now everything is perfectly fine, everything's happy. If I make an edit here, hello to JIT, it will, you can see here now there's an error in front of the file, which means the file has changed. I have changed that I didn't commit. If I commit now, now I can see here only this file has changed. I can also show see what has changed. So if I right-click, compare with head version, you can see that I inserted this line, which is pretty nice. I can double-check before I commit something what my commit is actually doing, and then add a hello message, and say commit again, and this error will disappear. So what if I want to do something more advanced with Git, like for example, have a look at the history. I mean, I don't know about you, but looking at the history in the command line, and for me, it's a little bit rough. So I like to have a look at the history in here in a graphical editor. So show in history. That's a strange history. Let me just double check. Team. Show in history. We change it somewhere. The history should look a little different. Okay, let's get to the history in a different way. We have up here we have the Java view, we have the debug view. What about the Git view? Is there a Git view? And yes, there is a Git view. So let's just open the Git view. And I can see my repositories here that I created. I only have one repository. And what happens if I hit this repository here? Oh, they might have changed the history a little bit. Okay, I have one branch, one local branch. What about if we make a new branch? Switch to new branch, test. We have a test branch now. Let's just make a commit to the test branch. The test branch. I just want to go switch back over to the Java version or Java perspective. Team commit. Go to the new branch. Say commit. How does the history look like now? The history used to look different. What's in here? Okay, I might have configured something correctly. Usually history should look something like, let's just have a little history of where I know how it looks like. I don't have anything here. How about I should have one in here. Sorry for all the switching back and forth. But here this is a JIT project that I have. Let's just have a look at the history here. Team. Show in history. Yeah, that's how the history should look like. Sorry that it doesn't look like that in the other view. I don't know why. You can see I've made several commits. You can see the commit messages, the authors, what has changed. You can have an immediate look at the differences. And also you have this lineup here. If you make a branch, that's why I made the branch in the other project, you can see like a branch appearing as a new line in your history view, which is pretty nice. So, but you have seen how to make a branch, which also is pretty helpful. Let's just team advanced. Okay, we probably have to switch to the JIT view again. How about if I want to merge them? Merge with master. So I have a test branch, I want to merge it with master again. Say merge. And now they should have been merged. Okay, apparently no conflict occurred, because otherwise the synchronization tab would open and we would be able to specify and manually solve conflict. All right. Since working with Git on your own laptop, on your own project is helpful, but not as helpful, or it helps you like track and keep with the changes. But it's a little bit more helpful if you work in a team. So let's just have a look at how working in a team works with the eGit. I'm just going to create a new project here in my GitHub. Okay, private test. I'm just going to call it test. Yeah, it doesn't matter much. All right. Okay, now I have this URL. The question is, how do I get the URL into Eclipse, that Eclipse works with that? I know that Eclipse won't have my login information. That might be a problem right now, because it will ask me to insert my login information. Anyway, let's just go to Git, and there's remotes. And the remotes are your remote Git servers, and I just want to create a new remote server. Let's just call it GitHub. I can change it to, oh, it already inserted for me, which is nice. And now it probably asks me for user and password. So I have to mute the screen for a second. I don't want anyone else to access my GitHub. So give me just a second to enter my credentials. Here we go. You can also store it in your password in like a secure storage. It's up to you whether you really trust whether it's really secure or not. For this demo, I'll just start in there. I say finish, and I can also do let's just do a dry push, nothing to push, okay. Save and save. Now I have the GitHub repository here. And now that's what I just want to push all my changes to my repository. You can easily do it here. Usually you go to team, as always. Then in your remotes, I just want to push something. So I'm specifying GitHub. I only have one remote, so nothing more will appear here. Sometimes you can just hit finish. I can't right now because I have to, let's just push master. And I want to add this. Yeah, I have to force it. I don't know how familiar you are with Git, but since I created a Git repository in my computer, and I created a separate Git repository on GitHub, if I want to push it without merging or synchronizing it in the first place, I'd have to force my push, but only for the first one. So I'm forcing it, and I say finish, and it was pushed to GitHub. So let's just have a look at the GitHub code. There's my test repository, and here we are. Everything is on GitHub. And we only have pushed the master. You can also browse all the history in here. Where are the commits? 2 commits. So everything what you did in Eclipse is on GitHub. So let's try the other way around. Let's just modify a file here. Let's just modify this. Can I modify it? Yes, I can. Oh, I never did that. That's nice. Hello world from GitHub. If I save it, probably ask me for a commit. Yeah, commit changes. Example for pull. Oh, commit changes. I now have. Oh no, that's not what I wanted. I now have somewhere in here 3 commits. Yeah, but local. I only have 2 commits. So what I want to do now is I want to update my local file of my project. So I go here, say team. You can, by the way, specify like the remote as a default, and then you can just hit that button and also remote default branches that you want to push and fetch. But I just going with that way for a second. So fetching. I want to fetch just the master, yeah, add that, and then finish. And it updated, but it updated in my master, not in my test branch, so just let me switch the branch again. Switch to the master branch, and in my master branch, it should have. Oh, I need to synchronize it probably. Do I have to synchronize it? Remote tracking, yeah, let me just synchronize it for a second. This might not always be necessary to synchronize the workspace. No, I don't wanna. And then I say push. I pull. Is it now? Where are my changes? Yes, it shows me my change. Let's just open the synchronize view for a second. Shows me my changes, that's what I want. Why don't you let me pull it? That's a little bit embarrassing, sorry for that. Okay, here we are. Nothing. Nobody has seen it, but I just switched over to the remote branch. It's just a Git specific issue, but now I'm at the remote branch, and now I see the GitHub there. Okay, that's how you work with eGit. So we've seen now that we can work with Eclipse for Java, we can work with Eclipse for C++, that's what I've shown you now. You know that it's like a plugin-based system where we can install plugins, you can customize it however you want. We have seen the notion of workspaces, that you can switch back and forth workspaces. We have seen the notion of views, that you can have views inside of perspectives, that you can switch back and forth between perspectives. We had a look at formatting, cleanup, refactoring, like renaming a variable. We've seen handy things like being able to find the references, the local history, then the history with Git. I think this should be the most important thing. I mean, we have seen the code completion, where I can, just again, because we did it a while ago, dot something, and it will automatically give me a few possibilities. We've seen that. We've seen the quick fixes where I made an error and it warned me immediately in the environment. I was able to make a quick fix, so just looking at the possible fixes for that and then being able to specify one quick fix for that. We have seen debugging, that we can step over our project. We have seen debugging in C++ in Java, and as you've seen, it looks pretty similar. And one last thing that might work, I hopefully have the correct plugins for that installed, is which is pretty handy for C and C++, is gprof and gcoff. Gcoff, I hopefully pronounced it correctly. Gcoff, for example, is a tool, and also Valgrid, that gives you, if you run a program, that specifies, okay, how much code has been covered by running it. So for example, let's just make a quick example here. Oh no. I'm just going to make it quick and dirty. That's an old way of displaying an if. This is an old way of displaying two ifs. So this is one if block. This is one if block. And if it's true, I think it goes to the left. True, and this is false. And there's the if condition expression. And you can, if you run your program, for example, and you run it once, and the code will only be executed once, you have like a branch through your ifs. So for example, you go through this, and then you will go through maybe that. So the code coverage here is not fully covering your test case or your test you're running, your program you're running, or it's not testing or not executing all the code that you have. So gcoff, for example, can be used to test how much code has been covered, how much, whether everything has been executed. So there is, in Linux, there is the set of Linux tools, namely gcoff, gprof, prof, valgrid, and another ones that I don't remember right now. But here we are, mace. Let's just have a look at that. You can see the Gmon here. Let's just say Linux tools somewhere. Where is it? I think it's profile. No, profiling tools. Okay, this profiling tools are the Linux tools. You can see profile code coverage. That's the gcode that I told you about. Hopefully it works. I didn't configure it before coming here. Okay, that's why I expected. Yeah. Okay. It gives you a summary of lines that you covered, and usually you have to specify in the compiler that you want to generate certain information, that you are able to do something like that. So let's just specify. By the way, you just seen I switched back to the project properties, and there should be other flags coverage. Maybe it's also here. No, it isn't. Hopefully it will work. I didn't do this in a long time. Usually nowadays you have more unit tests and automated tools Just thought it might be interesting to show it to you right away. I have to recompile it. And now... Oh, it probably complains geekhoff in it. Yeah. Let's just skip the geekhoff for a second. Sorry for that. But gprof should work. So if I have... what is profiling? Profiling, maybe not every one of you heard of that before. Profiling is if you have your program, you're running it, and it's not running as fast as you expect, you need to optimize it. You can think about what you did and what might take the most time, and then profile that way, but optimize that way. But profiling is a way better way to do it. Profiling will automatically time your code for you. Will tell you, okay, I executed this function this dozens of times, and will give you information about how much the execution time per function will be. So you will have information about where are you spending the time in your code, so you can localize the bottlenecks and then target the bottlenecks. So let's just profile the timing here. Binary not found? What? Oh. Okay, yeah, let's try again. I just recompiled it because the previous compilation failed. Profile timing. Yeah. Hopefully we can cut it out later in the video because it's a little bit embarrassing it's not working. The problem with gprof and geekhoff is sometimes you have to specify a lot of things in advance. Yeah, that's what I thought. But valgrid will probably work. Let's just have a look at valgrid. And I'll tell you something about valgrid in a second. Yeah, valgrid works. Okay. With C and C++, if you're malloking memory, you always have to free it, and sometimes can be a little bit dull task to keep track of all the allocations and freeing the memory, and you will have sometimes like forgot about freeing the memory, and we will have garbage in the memory. So let's just make a small test case where we will end up with garbage. So if, for example, I have a main, in the main I have an int test equals malloc size of int times 100. So if I just run it like that, I didn't specify free anywhere, so I have a memory leak basically. If I run it with gprof now, with valgrid now, it will probably hint me, or give me a hint that I'm not freeing the memory. So I was unable to show you coverage and profiling, but at least hopefully we'll be able to show you valgrid. Yeah, 400 bytes in one blocks are definitely lost in loss record 1 of 1. So it told me that I am losing memory, and it also tells me that I'm losing memory here. It highlights the line. So that's pretty nice to have something like that. So for the next time, if you submit any assignments, homework assignments, you can just check with valgrid in advance, and maybe it will tell you to have like a memory bug somewhere. Anyway, so we have seen those little tools, and sorry for the hiccup that it didn't work perfectly fine. To conclude, or to sum up the introduction to Eclipse, I want to show you some other versions of Eclipse that are out there in the field, like I told you in the beginning. So just for example, one thing I worked with was, for example, hopefully the internet will not be that slow for the next couple of 5 minutes, because I will be needing it. Oh, it's apparently that slow that you can't even see anything up here anymore. It's even slower than I expected. It's not working anymore. Oh, it's working again. Ha, very nice. We're lucky. Okay. There's the thing called PLC. If you have like, okay, let's have a look at PLC first, so you have a good understanding. Okay, these are programmable logic controllers. They are used in small machines, like if you have a robot or something that moves its arm in like an industry in a factory. Sometimes, or most of the time, oh no, they are done with a different technique. But machines are like driven with those PLC devices because they are like certified to work in rough environments, and they have certain security features. That's why you use something like that in in factories. And code assist is an Eclipse environment. Does that work? Yeah. It's an Eclipse environment that's apparently probably an older version. Here we go. That helps you developing for the PLCs in like an Eclipse environment. So that's how you're used to it. You have like, do we have a project view? Not really. That's also, just have to find the current version. Which also not, okay. Yeah, that's, it looks basically similar to Eclipse, what you've seen previously. You have this view on the side. You have then in the right side, in the main content, you have your all the things that you need for development. You have this additional windows like here. It says Fehler. It's just called error. And I wanted to show you this particularly because they spend a lot of time integrating all the graphical editors in there. So for PLCs, you often have like these flowcharts on the right, or these diagrams, and it takes a lot of effort to program those. That's why I want to show them to you, that you can they really tailor Eclipse in a way that you can use a graphical graphical editor and drag and drop all the things and create flowcharts. I wanted to show you that because of this. Then we will be seeing Xtext later. Do I have Xtext open? No, I don't. Xtext is a tool that I'm using for developing domain-specific languages. So it basically looks similar again. You have a navigation on the left side, you have your code on the right side. And as you have seen earlier, I switched over to this Eclipse environment earlier. This is Eclipse for my Android development. So I develop Java and C++ in Android, so I have a Java and C++ perspective. And I have this DDMS perspective, which will give me information about connected devices. Apparently, I don't have any connected devices, so there is nothing about that. But that's like the plugin that you download for the Eclipse for the Android development. But I can at least show you something else, which is pretty nice. For developing on Android, you have like layouts, and they have this layout editor, and you can use this layout editor for basically drag and drop in all the things that you want. Will that work? No. Okay, let's just make a new one. New Android layout file. Yeah. Test. Publish. Yeah. What did I do here? That's apparently a little weird. Okay, I'm just going to place it here. That should work. Relative layout. Okay, I think that you can imagine what you can do here, like drag and dropping all the GUI edit elements into your activity, and then specifying the GUI that way. Why this might be a nice approach, most of the time people go with that and just edit the XML file that is being used in the background. Anyway, it's nice to see that this is possible with Eclipse. So also sometimes you will have other programming languages, like I, for example, currently have to develop in Scheme, Prolog, and Haskell. And sometimes you want to use Eclipse for that. So I have a separate Eclipse that I particularly use for developing Prolog and Scheme. If I go to Scheme and then open something up in Scheme, it just behaves like you're expected to behave. We have the syntax highlighting, all these neat features that basically you can hit run up here, it'll run, and all these things that you're used to with other environments. So how about if you want to develop like something on an embedded microcontroller like a Netmega? There's something called the Atmos Studio. They nowadays use the Eclipse environment. Oh, they don't here. Okay. How about the wireframe sketcher? Oh, here you see, that's a really nice example. This looks really similar to what you've seen earlier with, you have your project explorer, you have an outline even, and you have certain other views, and you can specify with the wireframe sketcher like graphical mockups for tools, and they used Eclipse for that. Was pretty nice. And you can see it's like we haven't seen like a graphical editor in Eclipse previously, so that's pretty nice to have, to be able to do something with Eclipse. Also, I mean, Rational Studio. Just have to Studio, yeah. That's not the best example. That's no. Image. Okay, sorry why that's so small, but this is also basically based on top of Eclipse, and also again it's like it's a UML editor tool, a unified model language, which is being used to design software architecture, software environments. Basically, a topic that's been resides within software engineering, and you can specify like your architecture with UML in Eclipse, and then will automatically generate the code for you, and they used Eclipse for that. So, to sum it all up, we have started with how to get Eclipse. You know about that. You know that there are certain packages. You know that Eclipse is being used for certain environments, for certain programming languages, like I showed you in the end, for like embedded devices, for programming, like for PLCs, for like graphical user interface editing, stuff like that. Also for how you've seen it in the beginning with Java and C++ for the basic things, but you can tailor towards whatever you want. And you'll probably be seeing Eclipse more often in your life. So that's pretty good to understand, or at least be comfortable with it. Then we have seen how to basically use the editor itself with the code completion, the automatically generating code, formatting code. We've seen the concepts of using projects in the outside of your workspace, of using the perspectives. So in the end, my question to the audience is: are there any questions left? Or are there any questions at all? Because I didn't ask them. You didn't ask them so far. No questions. I would really like to see some or hear some questions. Okay, Parker.
How robust? I mean, you showed us the plugins.
Uh-huh.
I mean, how are there a lot of are there repositories that are there places you would go to find ones that you trust?
Well,
Isn't the official ones?
You've seen the marketplace. So basically, everyone can submit their stuff in the marketplace, and they have a rating there. So it's like in the App Store, you can give 5 stars or something. You can leave a review.
So if it's highly rated, you would consider that, trustworthy?
Highly rated and also highly used. If something is highly used, you can. I mean, it's probably perfectly fine, I guess. No other questions. Kai?
So if you wanted to use Eclipse on a Windows or something other than Linux,
Yep.
What differences would you have to do as far as like compiler-wise?
Okay. For Java, you don't need to do anything. By the way, you need to have Java installed if you want to use Eclipse in the first place. But for Java development, just running Eclipse will already work, and you can already run all this stuff because you already have Java in your computer. For the C++ development, there is something called minimalistic GNU for Windows. It's basically the GCC that you use for Windows, of Linux, but for Windows you can download that. Then once you install it, you can, when you create a new C project in the Windows machine, you can specify the path to the environment, to the MinGW environment. And that way you are able to compile on Windows. You can also go the way and just download Visual C++, which is nowadays part of the Visual Studio. So download Visual Studio. Visual Studio will install Visual C++, and then you can specify the path to the Visual C++ compiler if you want to use that instead of the GCC or MinGW compiler, MinGW compiler. I mean, for the other programming languages like Prolog, Scheme, Haskell, you always usually have some environment that you have to install on top of that.
Is there any compatibility between Eclipse and Visual Studio, or any sort of trade-off, or are they kind of separate?
Okay, Visual Studio is like a really old tool from Microsoft. It's probably as old as Eclipse. So Visual Studio back in the days was the commercial environment, and Eclipse was the open source environment. Well, nowadays Visual Studio is like highly supported through Microsoft itself, and then nowadays give you like a free version. It doesn't have all the full features of like the full version. Like for example, I don't think that it has a profiler tool in it, the free version. I mean, I also was unable to show you the profiler in Eclipse and GCC, but it should work actually. The big difference between Microsoft Visual Studio and Eclipse is that Microsoft Visual Studio, you can develop plugins and stuff like that, but the community for developing plugins and tailoring the development environment towards their needs is bigger in Eclipse. I mean, they do the same things with Visual Studio. They are also like the Atmos Studio that I wanted to show you about, which you're using for embedded microcontrollers. I think they used to use Visual Studio at one point in time, but the newest version transitioned over to Eclipse, similar to CodeAssist. What made it different for me to find like a screenshot of CodeAssist that uses Eclipse is that they used a different development environment previously and transitioned over to Eclipse. So there's like a big movement, everything towards Eclipse because it's open source, because there's a big community in the background, but there are also plugins available for Visual Studio.
If you compile something in Eclipse, is there a way if you suppose you want to run it from the terminal, what would you do? Where does the code live?
Let me just check, show that to you for a second. This is the C++ Eclipse that I showed you earlier. You can see here, this is the Maze project that I used a few times. I told you that if you compile, there will be this debug folder. So that's just, and you can see here's the debug folder also, if I open it inside here. Okay, hopefully this font size of my editor is too small. Okay, let me just increase the font size for a second. Here we go, that's a bigger font. This is my project. I compiled in the created debug folder. So let me just navigate over to the debug folder. Here we are, and in the debug folder you will have this executable is named, usually like your project is named. So if I just type that, it is just the binary. And you can also just work with the binary. So if I type GDB and Maze, you can just use everything inside of GDB out too. So it's exactly the same. You can, if you use the release environment instead of the debug environment, it will. Let's just do it for a second. Release. It will create a release folder here, and in the release folder, do I specify release right now? Do I have to update it? Why does it not want to do my release version? Does it? No. No, it's not lazy key. What is it compiling here? Oh, yeah, I see. Just specified the release version, but it didn't compile because in my release configurations, I didn't specify C99. Let me just specify C99. I can set to the release version. Now, yeah, here we go. Now it created a release binary, and this release binary does have the optimization enabled and no debug information in it. So we can, that answers your question probably. You can use that file, not if you want to release the binary. And since we are talking about that, let me just show you something. We have this make file here, and basically all the configuration that you're making in the project properties resemble some changes in the make file. So the make file looks pretty big, and all changes that you're making in the project properties resemble somewhere in here. So did I specify stdd somewhere? Here we go. The stdd, for example, is specified here. So what Eclipse does in the background for C++ generate those 4 files, the make file, the MK, these 3 MKs. And I can also go in the command line and just specify make. Oh, nothing is, we don't need to do anything. Just change anything. If I hit make now, it will just, what? Doesn't make anything. Am I editing the right file? Here we go. You can just use the make command as I used to previously without using Eclipse. So it's basically, especially with C++, most of the things are like a graphical user interface for the things that you're already using. And it's just a little bit more convenient sometimes, as you've seen with the debugger especially. They can change variables on the fly, and you don't need to know how the commands for the GDB look like, and just use a mouse, click inside of it, and change the value. That's perfectly fine. Okay, Justin?
So it automatically will generate your make file for you when you compile it?
Yeah, like through the settings that you made in the properties. So if let's just emphasize this for a second again. Where's my maze? Here we go. Damn it. Properties. Let's just add an include library here. I just that doesn't make sense, but just want to have something in here. So I changed an include library in the release. So in the release, it should emphasize somewhere. Is it here? Not here. Is it here? Where is my include file? I want to see my include directory. Do I have to build it first? Interesting. Where's my include file? Maybe it has been omitted. Let me just double check. Include parse, C compiler. Okay, good question. I don't know why it doesn't give me the include files in somewhere in here. Usually you see all the changes that you're making with the graphical user interface somewhere in here. You just have to find them. Oh, here it is. Didn't see it. So it now added this line here to the make file. And I highly recommend not modifying these files, because if you change them, the Eclipse, the C++ plugin for Eclipse might not understand them anymore, because it expects them to be in a certain format. So if you use that, then make changes with the graphical user interface. And thank you for all your attention. That's it from my side. We'll be doing a lab afterwards where you're going to apply some of your newly learned knowledge. Thank you.